Go for Unit 5, Lesson 1 homework. We're looking at two scenarios here. The first page is a t-shirt shop. Second page is towing services. Okay, so we have a whole page just dedicated to this story. So here is our story. Your new job at the custom t-shirt shop where t-shirts is at the custom t-shirt shop where t-shirts are printed to order. For each order, custom t-shop charges $8 per shirt. Now I'm seeing that per shirt, and I'm remembering that every time I see per mile, per shirt, per hour, that is a constant rate. Okay, so I'm seeing that that is a constant rate, which tells me that is the variable m, which always represents our slope. Okay, plus a one-time fee of $15. That fee happens once and only once. Okay, so that will be our variable b, which we know is our y-intercept. I can go ahead and write my equation. So y equals 8x, that is $8 per shirt. So that means that x means amount of shirts. $8 per shirt, so 8 times however many shirts you have, plus that $15 startup fee. That means that y, when you do all of that math here, you're going to end up with y, which is our total amount or total cost we're paying for the order. Okay, so x here is our independent variable. Okay, so we can determine how many shirts. We can say we bought 1 shirt, 2 shirts. Y depends on how many shirts we bought. So the total cost is affected by how many shirts we have. Okay, down here we can do our table of values. Always start with x being 0. When we buy 0 shirts, you can even just show the math here. We have 8 x, which is now 0, plus 15. Well, that's just going to be 15. Okay, well, what if we bought 1 shirt? 8 times 1 plus 15, that'll be $23. And 2 shirts would be 8 times 2 plus 15. So sorry, 15. That'll be $31. We can convert those points, these numerical values, into points by just doing 0, 15, 1, 23, and 2, 31. Okay, we can take those points and graph them. I'm going to use the edges of the graph as my x and y. So this is my y-axis and my x-axis. We always need to label graphs. So x represents the amount of shirts. My y-axis is my total cost. I need to label with some numbers here. My x values are all pretty small, so I'm just going to go by ones here. All right, and my y values get pretty large pretty quickly, so I'm going to go by 5s here. Okay. All right, here we go. So let's plot 0, 15. 0, 15. 1, 23 is going to be pretty much halfway in between 20 and 25. And 2, 31. Line those up. It is a linear function. It is a straight line. And there is our line. Now you might have had different values on the side, which is totally fine. You'll still have a straight line. All right, and to the back side, here we go. Here's our other story. When a tow truck is called, the cost per service is $10. So that is no matter how many miles they're driving, you will pay that $10 fee. So that is my B. Okay, it does not depend on how many miles I'm driving. I'm always going to pay that $10 extra fee. Okay, plus 1 per mile. And there's that magic word per. Whenever I see that, I know it's my constant rate, which is our slope for m. So I can go ahead and write my equation. Well, it'll be 1x, which is just x, plus that $10 fee, okay? X represents the amount of miles you're driving, okay? And Y will be your total cost that you're paying for the towing services, okay? And it says, write a graph, linear equation to represent the total cost of the towing services, which is the dependent, okay, total cost is dependent on the number of miles, which is independent. And remember that independent is always X, dependent is always Y, so that's also how I got those define your variable section. All right, looking down at the table, always start with X being 0. So if I did 0 miles plus the $10 fee, it'll cost me $10. Okay, 1 mile with that $10 fee will cost me $11. And 2 miles and that $10 fee is $12. Okay, so my points are 0, 10, 1, 11, 2, 12. Okay. Same thing, I'm probably just going to use the edges of my graph of my X and Y axis. Okay. We always label, so X is the amount of miles, and Y is going to be my total cost. Our numbers are all pretty small here, so I'm just going to go by ones. I like to spread my numbers out so I have a lot of room to read the graph. Here I'm probably not going to skip because I won't have enough room, so just 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 0, 10, so 0, 10. And then we have 1, 11, 2, and 12. Connect our line or our dots to make a line. This is a linear function because everything's changing at the same rate, and we're drawing a straight line all the way through, and that is what our graph looks like. Obviously, you may have different values. That's okay. Your line should still be straight. And there's the homework.